Hello, everyone. My name is Judith Nkechinyere, Njoku, and I'm a researcher here at the ICT Convergence Research Center. And the focus of my talk today will be about how you can apply Metaverse in transportation systems to make them more intelligent. My hope is that at the end of this discussion, we would have gained insight into how the transport system. Well, just a minute, let me increase my volume. I think there's an issue with my volume. Okay. Is it fine now? Is it okay? Okay. So I hope that by the end of this discussion, you'll have gained insight into how ITS, let's say ITS for short, how it works. You understand what technology drives autonomous vehicles, and also gain insight into how Metaverse can influence autonomous vehicles. So first things first, what is ITS? What is intelligent transport systems? This simply refers to the use of information and computer technology to make transportation system smarter. So it could be vehicles, aircrafts, trains, subways, whatever. As long as there's a means by which you can make it smarter, it becomes ITS. And the goal is just to provide reliable transport system, more comfortable transport system, and a more simplified operation and decision-making process. To understand ITS better, we need to look at the connections in ITS. And there are four major connections. The first is the vehicle to pedestrian connection, the vehicle to network connection, the vehicle to vehicle connection, and then the vehicle to infrastructure connection. In the vehicle to pedestrian connection, this encompasses people walking on the road, children being pushed in strollers, people using wheelchairs, and cyclists, amongst others. With this connection, vehicles can recognize pedestrians who are within their line of sight and prevents collision, like you can see in the figure over here. Next, we have the vehicle to network connection. Basically, this means that vehicles can connect to cellular networks and exchange information with other vehicles and other objects around them. So this gives the vehicle the power of connectivity, which we'll be looking at later on in this discussion. Then we have the vehicle to vehicle connection. In this network, vehicles can communicate with other vehicles about their speed, their location, their status, and of course, alert them about when they are within a very, very risky distance from the other vehicle to prevent crashes with the other vehicle. Last but not least, we have vehicle to infrastructure connection. Now, when we talk about infrastructure, we're referring to buildings, roadside units, traffic lights, things like that. In the case of infrastructures, they have a lot of data. For instance, traffic lights, smart traffic lights, have a lot of data about the traffic in the environment, and this is forwarded to the traffic management units. Now, cars can have access to this information and understand where to park, which parking spaces are available at any time, and also be warned about when they're about to jump the red lights or when the pedestrians are also crossing the road, so they can know when to stop, especially for autonomous vehicles. Okay, so let's look at some technologies that empower ITS. There are four main technologies: connectivity, Internet of Things, AI, and edge computing. Connectivity, in this case, because of the need for ITS to deal with massive amounts of data and transmit a lot of data and also process data in real time and give results in real time, is the one that we have a very ultra reliable and ultra low latency connectivity like 6G. So this is really critical to the success of ITS. Next, we have the Internet of Things. This is a kind of umbrella that covers objects that are linked or connected with internet. Objects here refers to vehicles, humans, infrastructures, buildings, and the rest of them. This is one of the bedrock of ITS. Next, we have artificial intelligence. Of course, with ITS, we have a lot of data being generated. Lots of data being on an hourly basis. You have a lot of data per minute, lots of data being generated. And this is used to give the vehicle power of processing and decision making. So this is very concrete to the source of ITS. Then we also have edge computing. Unlike in the case of where you have data being processed at the cloud and maybe the results being sent to the vehicle, it's better to have it processed at the edge so that to enable real-time response to incidents, you can have a very, very quick process of data processing, data reception and data processing, and then feedback to the vehicle. So these four elements are the core technologies of ITS. Now let's look at autonomous vehicles and the metaverse. An autonomous vehicle is a self-driving car, otherwise known as self-driving car. It's a kind of car or vehicle which has a level of automation. So it enables the vehicle to operate with minimal human intervention. Yes, and so far there are about 6 levels of autonomous vehicles. In the first level, there is no automation, which means that it's manual control. So the human performs all the tasks of steering, acceleration, braking, and the rest of them. Whereas in the second level, you have driver assistance, in which it monitors the speech through cruise control. So in this case, the human still does the entire driving of the vehicle. Then in the second level, you have partial automation. Here, the vehicle can do some tasks like steering and acceleration, but the human still monitors all the other tasks and can take control all the time. Now, the first 3 levels, the human monitors the driving environment. Now, let's look at the next 3 levels. In level 3, we have conditional automation. Here, the vehicle can detect things in the environment. However, the host still performs most driving tasks. In level 4, which is high automation, now the vehicle performs all driving tasks under specific circumstances. However, the human is still there to override when the need arises. Then we have the final level, level 5. This is a fully autonomous vehicle. Now, in this case, the vehicle can operate on its own without human intervention, and it has no need for human interaction. But this is not fully in place nowadays because it's a very risky situation. You can't have a vehicle driving on the road. When it comes to situations where it has to make a decision, for instance, if a human driver jumps the red lights, it doesn't know what to do because the vehicle is thinking. It's not trained to jump red lights. So it's a little risky to put it on the road right now. So it's not really fully in play. So today we'll be discussing based on cars that are level 4 automation, high automation. Okay, so let's look at the features of autonomous vehicles. First of all, autonomous vehicles have certain features which make them what we call autonomous. So first of all, we have the adaptive cruise control, and this means that this enables the vehicle to keep a certain distance between it and the one preceding it, and it can slow down and pace up in line with the other vehicle to prevent collision, of course. Then next, we have the autonomous emergency braking system, which is usually useful during traffic incidents and enables the vehicles to brake when it is very necessary and when they are at a very, very close range with the vehicle preceding it. And we have the lane keeping assistance. This is a technology that enables vehicles to drive within the prescribed lane on the road. Most times, the vehicles have a kind of guidance in the vehicle, which steers the front wheels of the car in line with the lanes. And then we have blind spot detection. This provides a kind of 360-degree coverage of the entire vehicle, allowing it to detect when vehicles are within their blind spots to avoid collision with vehicles overtaking. Then we have the reverse park assists, and this technology gives vehicles audio and video assistance in parking to prevent reverse accidents. Last but not least, we have object detection and recognition. So in this case, vehicles have the ability to detect vehicles within their line of view and also objects like pedestrians, traffic signs, and other infrastructures. Okay, so next we look at the metaverse itself. We've heard so many speakers talk about the metaverse, and you can see how exciting autonomous vehicles are already without the metaverse. You wonder what next, what can the metaverse offer? Let's look at what exactly metaverse entails for a start. Now, we have virtual reality. Like we already know, this is just going to be a brush up on what this means. This is a technology that allows users to control objects virtually or remotely using a VR remote control. While augmented reality enables users to see the real world overlaid with a kind of digital elements. So in ITS, this is very, very well explored for transportation systems. Next, we'll look at mixed reality. And this is a kind of fusion of AR and VR and allows for you to interact with virtual objects in the real life environments. Then the last but not least, we have extended reality, which encompasses all of these technologies into one. So you can actually control virtual objects from a distance and control real life objects from a distance. It's a fusion of both the real and the virtual world into one. Then we have the digital twin. Digital twin represents the digital form of real world objects. So processes, scenarios, or systems can be made into a digital twin. This works in a synchronized fashion with the real world object. And it means that you can actually have changes made to the real one and then fused to the virtual one and vice versa. So when changes occur in the virtual world, you can make your changes there and also come and reflect it back in the real copy of the scenario or the object. Then we also have avatar. So like we are used to viewing avatars in computer games and the rest of them. But in the metaverse, avatars are human figures that represent human figures. So it means that the way you can control avatars in computer games, in the metaverse, once you make a gesture as a human, your avatar also makes the same gesture. So it's synchronized with the avatars in the metaverse. Then we have the metaverse itself, which of course, like we know, is a virtual world, which allows for interactions with different kinds of persons from different parts of the world. As you can see in this video, we have two persons playing a game, an avatar and a real human. Now the avatar, of course, is somebody else who is accessing this particular location remotely using VR. So we have virtual reality in place here. Then we have also augmented reality. You can see that the ball that is being passed back and forth is a virtual object, but it's in place in a real world environment. And the person that is playing the game on the other end is also a real human playing against an avatar. So this shows you how all of this is incorporated into the metaverse to make it a reality. We also, of course, can see the avatars and all of this. These are all features of metaverse. The game board is a replica of a real life object, which is a digital twin. And it's already been shared by both a virtual human and a real life human. Okay, so people might ask, why do we need this union? Why do you need metaverse? We already have a very wonderful vehicular system that is autonomous, that serves so many functions. Why do we need this union? Why do we need to have metaverse in vehicles? Okay, let's back up a little bit. Let's think about how much attention we have so far from metaverse in the social world, financially, and like we saw yesterday, we saw about the manufacturing industry. Now, there's a question that we need to ask ourselves. If we are heading for the future in which we can be anywhere virtually, we don't need to be anywhere physically, why and how do we move around the world? How do we move around? This is where transportation comes into play. With that question in mind, there are two big feature characteristics of human mobility in a world in which metaverse is in control. First of all travel is leisure travel, and commuting is a cake. Now, this might sound controversial. How can all travel be leisure travel? How can commuting be a cake? I'll explain that a bit. Since the COVID pandemic, so many businesses embrace remote work, remote meetings, and remote activities and the likes. And surprisingly, they all thrived. We didn't hear of businesses folding up. They somehow managed to go on with the COVID pandemic. How was this possible? This means that things like business travels became unnecessary. People could resort to Zoom and the likes to have business meetings. Can you imagine it took a pandemic for the world to realize that traveling for 14 hours from wherever in the world to Seattle or Shanghai just to have eye contacts and exchange handshakes was not necessary. It was a waste of resources. So just imagine that at this point, it becomes very unnecessary to travel for businesses. It means that in the future, with our future aircraft and future means of transport, people will only travel for leisure. And what do people who go on for travel and leisure do? They go to connect with people and to have fun. Now, in order for you to have transport systems that can enable people to connect with each other and also have fun, we need to have a complete overhaul of the entire travel system. This is where the metaverse comes into play. Metaverse will help to transform airports, aircraft, train terminals, trains, and other transit systems. Now, let's look at how this is possible. To understand this, we look at some case studies of what has already been done by two companies, the Nissan Global and then Wayray. The Nissan Global introduced what is called the invisible to visible technology, while the Wayray introduced Metaverse on wheels. Now, these are two concept cars. Nissan Global's own isn't really really a product yet, a full functional car. However, where technology has introduced a fully functional, should I say partially functional vehicle, but the concept is still based on metaverse. Now let's look at the first one, the invisible to visible technology. This technology by Nissan Global is based on a 3D augmented reality interface that merges the real and the virtual world to make information that is invisible visible. That's the basic idea, to make the invisible information become visible. Now, it's based on a technology that is only patented to Nissan, based on Omniscient Cloud. Now, this is a virtual hub that gathers data in real time from traffic environments and the vehicle's exterior and exterior. The vehicle's exterior could refer to the cars around it, the buildings around it, and all of that. While the interior could refer to the countenance of the driver or its passengers of the vehicle. So this is the kind of data that this gathers. I mentioned before about digital twin. Digital twin becomes possible through sensors around the vehicle, which generates data about the environment and also replicates it in the digital environment. Next, we have the seamless autonomous mobility technology, which helps to analyze the road environment through relevant real-time information. So this helps vehicles to make decisions, which we'll be looking at later on in this discussion. Then we have the Pro Pilot. Now, this helps vehicles with sensors to gather data. This enables the Omniscient Cloud to have what data it needs to process for the vehicles to make decisions. Then we have the digital twin, which I have mentioned earlier as the digital replica of the physical world, made possible through data gathered in Omniscient technology. Now we'll look at a short demo of this. Okay, so I'll just tone down the audio. So I just want you to see how this vehicle works. This is just a short demo. You can see that this vehicle allows you to interact with the environment. You can see when you want to park. You can see the windshield of the vehicle has some kind of writing on it. That is made possible through augmented reality. Okay, so you can see the weather can change. Through the vehicle, you can change the weather from foggy to bright weather. I'll also explain that later. Okay, you can have an avatar also join you during the ride on the vehicle. So I want to observe the windshield, the dashboard rather of the vehicle, and you can see just, okay, so let me talk about what's, can you hear me? Let's talk about what this technology or this concept car is trying to offer. First of all, it says that it's offering visualizing invisible information for a more comfortable and exciting drive. That was a very short demonstration, but I want to explain more because I don't have much time. So first of all, there are different scenarios we want to paint using that vehicle. The typical driving scenario. In this scenario, the system will display information about the road environment, such as potential hidden obstacles or pedestrians, or on the dashboard of the vehicle. Then, in a traffic congestion scenario, the system will display upcoming traffic situations, including those that you can't even see them, and then the causes of them, and so the driver can make a detour and decide on what other route to take. Then, in a typical parking scenario, the system displays where and when the next parking space will become available, like we saw in that short clip earlier on. In a mountain driving scenario, the system will project an image of oncoming vehicles or an obstruction, so that the autonomous vehicle knows what other paths to take or when to stop. So this allows for it to make certain decisions. Then, in an autonomous driving scenario, system can project a scene of clear skies on the vehicle windows, especially when the weather is in poor condition. So those who are on the ride can get to experience a better driving experience instead of having to suffer through maybe a fog or something. So next, look at the second offering of this technology, visualizing human-to-human virtual communication for a new connected car experience. Now, there are different scenarios here. First of all, we have a companion scenario. Now, this means that a friend from anywhere in the world can join you as an avatar on that trip via the metaverse. So you want to drive and you feel like I'm in Korea right now, my mom can join me from Nigeria on a ride in the metaverse. And that will make me feel less lonely or make me feel that I have that feeling of interaction while driving. This points back to what I talk about leisure traveling. Next, we have tourism scenario. Now you're going to destination, you need a local guide to inform you about that area. Someone can join you from Metaverse as an avatar to answer questions and give you recommendations on places to visit in real time. Then we have the service scenario. You also learn how to drive. You need someone to teach you. You can have a pro that join you through the Metaverse as an avatar and assist you in real time. Then, okay, look at the second case study, which is Metaverse on Wheels by Were. So this is a technology based on something called holographic deep reality display technology. And they have a fully functional car called the Were Holograptor, and also called the Metaverse on Wheels. I'll be explaining this in a bit. First of all, the technology basically based on augmented reality allows for the dashboard of the vehicle to have virtual images appear on it. So for instance, you can see in the image here, you can see some objects that are at certain distance are being displayed on the dashboard. Even the aircraft at the farthest distance is also being displayed on the dashboard. So this allows the vehicle to view information about human beings, about buildings, about vehicles, right on the dashboard. This is going to be a replacement for the traditional dashboard we have, which is just a plain windshield. This is going to be a virtual dashboard fused with the real world, all in one space. And then we have so this is how technology works. I won't be explaining this in detail, but just something to note. This, in this vehicle, we have a device which has several parts. The beauty of it is that you can put this into any autonomous vehicle. It doesn't have to be the Were Holograptor. You can actually take this out and put in a different vehicle for it to function as a Metaverse vehicle. And then we also have, okay, let's look at a case study first, then I will explain. Okay, so we can see this vehicle. You can see there's the red line marking as it approaches the vehicle in front of it, which is a kind of alarm that shows that it is already within a very unsafe proximity with the next vehicle. Then you can observe the blue lines, which is a kind of trail to show that it has to turn, show kind of direction for the vehicle. This is all made possible by augmented reality. Then on the dashboard, you can see some kind of lecturings about the distance traveled, the speed of the vehicle, also the map. As you're turning, the map is also turning. Now you can see pedestrians crossing. It can detect pedestrians who are crossing, and also you can see a kind of alarm sign that shows that you have to stop. Now, see information about pharmacies, that's the location around. So you can see data about the buildings around, locations, and all of that. Now let's see. Okay, you can observe the blue lines also. As you turn, there's the direction sign which shows that yes, you have to turn right or you're turning right. You also have a notification that shows when you've arrived at a location. Yeah, so you have arrived. You have arrived. Okay, there's something more. You can see lane markings. Like I mentioned earlier, a lane tracking. In this vehicle, you can see that once you go beyond the lane, the line changes from blue to red, which shows that this is a risk and you should remain within your lane. So it helps to guide the vehicle. Once the alarm goes off, it tries to maintain the lane and remain within that the blue line markings. Also, it can monitor vehicles ahead of it, and it turns red once it gets too close to those vehicles. You see, like once it gets too close, it turns red and an alarm is shown, which means you have to slow down on your driving. So this essentially shows you how Metaverse can actually help to make driving much more convenient, much more comfortable, and much more reliable. Now, what does this vehicle offer? It offers what they call AR glazing. Now, AR glazing allows you, or augmented reality glazing allows you to view and visualize different objects from your the vehicle's dashboard. So you can see lane markings of the road, you can see other vehicles. Even by the left, you can see this vehicle colored purple. It's actually a virtual vehicle riding on the main road, not a real vehicle. You can also see information about different buildings around, the traffic light, and the rest of them. And then we have the remote control. Now, this is the beauty of the Were Holograptor. The idea is that anybody from any part of the world can actually control this vehicle and drive you around. So it means that I could be here in South Korea and I need to drive somebody back home in Nigeria. I just access the vehicle wherever it is and drive the person where I need to drive the person to. So this allows for remote control of vehicles. And this has given rise to what we call the ride-hailing service. So you can have Uber for the Metaverse. For the Metaverse, someone can actually request an Uber and you can drive the person around. And this allows also for drivers to work remotely. Isn't that just beautiful? Then we have the air knife. It became popular due to COVID-19 pandemic, and it allows you to have shared rights with other persons in the vehicle, and gives a kind of layer of protection to prevent for transmission of infections of airborne diseases. Okay, so this is a very wonderful technology, Metaverse for transportation systems, there are also some issues that, should I say, need to be also looked into while innovation goes on. For instance, network or connectivity issues. What happens if I'm driving somebody from Korea in Nigeria and they suddenly will lose connection with internet? What happens? What happens to the guy over there? Have crashes, accidents? So these are things that need to be put into consideration in where this is deployed and how it is deployed. We also have security issues, which I won't be going into now due to time, because our speaker will soon discuss about these security issues. Thank you very much. I hope I have been able to inform you about this particular topic. Thank you.